Hello everyone and welcome to the Math Blender by Adnan Zaidi. In this session we'll talk about exponential functions and precisely how the sketch of an exponential function looks like and what are the variations of it. So let me start off with what a basic exponential function or what a mathematical exponential equation is. So any equation where y equals to, let's say, 2 to the power of x. Now if you see that this is the variable and it is written as power. So whenever the variable is expressed in power, we call this an exponential mathematical equation. It could be y equals to 3 to the power of x, y equals to 100 to the power of x, y equals to e to the power of x. Note that this, this, all of these, the bases are constants. They have a value, but the powers are variable. They can change. So this is called an exponential equation. So all of them. So let's say if I have y equals to 2 to the power of x, and if I have to draw this, I'll I'll keep some random values. And if I keep on putting these values, and I'll see that y equals to 2 to the power 0 is 1. And if I'm putting these values as in the equation, this will be 1, 2, 4, 9. Now these y values are not proportionate. They are not adding to a certain proportion, and that is why it's an exponential function, because they're adding up exponentially. Now if I draw this function, and this is what I want you to understand first, that when x is 0, y is 1, so somewhere here let's call this point 1. Now if I have to draw this function, the shape of this function will look like this. This is a sketch of an exponential function where the equation is 2 to the power of x. The curriculum requires that all you need to know is the sketch of it. You don't have to draw it, and even if you have to draw it, you will be given a graph grid paper. But the sketch of it is all you need to remember: the point of intersection with the x-axis or y-axis. In this case, the x-axis where it intersects, let's look at that as well. Y equals to 2 to the power of x. Now if I want to find out where it intersects the x-axis, I'll place y as 0, 2 to the power of x. And if I apply ln both sides, or 2 to the power log 2 both sides, this will become x. And if in my calculator, if I place the value of log 2, I will see that this will be a math error, which means even the calculator will not be able to process what that value is, which we assume to be infinity. So this blue line, or the part of the curve, will keep on stretching until it meets the green line or the x-axis at some point, which we name as negative infinity in this case. So we say that at infinity, when x reaches infinity, this will touch the x-axis. So this is all you need to know. But how we represent that? We draw a dotted line here instead of the x-axis, And we say that this line here is called the asymptote. So an asymptote is a line to which the curve tries to approach, but in real terms it doesn't. It approaches at wherever the value reaches infinity, and infinity is unprocessable, we cannot process it. So that's why we just draw and show that the curve is approaching, but we don't show that it is touching. So let's look at the variation or type of this function. So this is a one-to-one function. If I want to write down what that is, so it is a one-to-one function, which means its inverse is possible, and we'll talk about it in the upcoming videos. The domain of this function is x belongs to real number, because as you could see, the curve stretches from negative x to positive x and it keeps on going. The range of this function is y is greater than 0, because it always lies above the asymptote, and in this scenario the asymptote is the x-axis, which is y equals to 0. So this is all you need to know about a basic exponential function. So this is a 2 to the power of x. The same sketch is for e to the power of x, 100 to the power of x, or any exponential function that you see. A basic exponential function will have exactly the same x values. Now let's look at, I'll take e to the power of x as my prime example. So let's take at f of x as equals to e to the power of x and try to draw them. Now this is my basic graph, and I will show that the graph is approaching the line x-axis, which is an asymptote. This point here is 0, 1, or the y-intercept. If I say that f of x plus 2, then the equation becomes y equals to, since f of x was e to the power of x plus 2, and this makes the graph shift 2 units up. So all you have to do is you draw the same function, but since this function shifts 2 unit up, will now intersect at 0, 3. And the asymptote line, which was at y equals to 0, moving 2 units up, will reach y equals to 2. So this is y equals to 2, the asymptote line. It is lying above that. Now if I say that this graph had its domain x belongs to real number, the range was y greater than the asymptote value, this graph will have its domain x belongs to real number, but the range is now y greater than 2. Now let's look at another scenario. F of x minus 3. So this will make the graph shift 3 units down. Note that I'm In all of the scenarios that I'm taking the parent function and I'm just shuffling it up or down. That's all you need to remember when sketching. So this equation will become y equals to e to the power of x, which was the value of the parent function, minus 3, which means the graph shuffles, goes 3 units down. So if this is my x-axis, and since initially it was passing through 0, comma 1, and after shifting 3 units down, it will touch some this value, which is 0, comma minus 2. The asymptote which was at 0 is now at negative 3 after going 3 units down. The domain is x belongs to real number. The range is y is greater than negative 3. Okay, so we saw 3 scenarios where the graph was shifting up, down. Now let's look at another one where the graph or the parent function is stretching. So let's say if I say 2 times f of x, this means that the graph is stretching and it will be stretching in such a manner that whatever the value initially was is now 2 times that value. So this will become, since y was equals to, since f of x was e to the power of x, and 2 times f of x will become 2e to the power x. This is now so okay, so now since this value here, this was the curve, and let me erase. Now this is approaching the x-intercept, but it is not going to be touching it. So this value here, which was initially in the parent function as 0, comma 1, is now 0, comma 2. Every y value is multiplied with 2. You don't have to mention all the other values since it's just a sketch. The asymptote does not shifts or multiply. The asymptote remains where it was initially because it's not shifting since it's multiplying with 2, and since the y value of the asymptote, initial asymptote, was 0, so times with 2 makes it 0. So hence the asymptote remains where it was. So the domain is x belongs to real number, but the range of this function is y greater than 0. Now some other crucial graphs that we need to look into. Minus f of x. So this is reflection in y equals to 0, flips the graph on the y and the x-axis. Now if I have to convert this into the equation, then it will become, since f of x was e to the power of x, this will be negative e to the power of x, which is a reflection. And if I draw these axes, and since if this was the original function, the other function is going to look like this. So this is minus e to the power of x, since this was e to the power of x. The asymptote, since it's the reflection in this line, the asymptote remains the same, won't change. The range of this function is y is less than 0. The last one to look at is f of minus x. This is reflection in the x-axis, in the x equals to 0, or the y-axis. So I'm drawing the parent function and then I'll draw the other one. So if this was the original e to the power of x, the equation will become y equals to, since f of x was e to the power of x, and this negative sign inside makes this x becomes negative x. So the other graph is going to look like this. E to the power negative x, and this asymptote remains the same, and in this scenario domain and range of both the function remains the same. So domain x belongs to real number, range y is greater than 0. Okay, now let's look at some of the example questions that we have and try to see how they are in the context of our original lecture. So if I take the example as a, y equals to 2e to the power of x minus 4. I'll take this case stepwise. So first step, the parent function is e to the power of x, and if I have to draw this, it will look like and 0 comma 1 is the point it's passing through on the y-axis. From here we'll take this. So 2 times e to the power of x is the multiply, so which means the graph will have the same asymptote, but the y-intercept becomes, which was initially 0 comma 1, is now 0 comma times with 2, 0 comma 2. The asymptote remains the same. Then if I add a negative 4 to it, which means this graph is moving 4 units down. And if this graph moves 4 units down, so initially it was having 0 comma 2, that its touching point, that one we have, and it goes 4 units down, which means it will be passing through this point here is 0 comma negative 2. After moving 4 units down, the asymptote, which was initially at y equals to 0, by moving 4 units down will reach this point where y will be equals to negative 4. I can say that the domain is x belongs to real number, but the range is y is greater than -4. Now one more thing, as you could see that it has now the x-intercept, which means at that point, at this point, the y value is 0, and we need to find that out. So if we have to find that out, let's see how we can work on that. So 2e to the power of x minus 4, if I replace with 0, this will become 2e to the power of x is equals to 4. E to the power of x is equals to, divide both sides by 2, which makes it 2, and x is equals to ln 2. You can refer to the lecture related to logarithms to get an idea how I did that. So this x is equals to, this point here is ln 2 comma 0. Now let's look at another example. If I have y equals to -2 e to the power negative x plus 4. So we all know now, up till now, what a parent function looks like. So straight away, as I could see that e to the power negative x is going to look like this, passing through the same 0 comma 1. Then if I multiply it with a -2, then the same thing. So this here, this value here is not only multiplying, but since there's a negative sign as well, it's also reflecting. The graph looks like this. So the point which was 0 comma 1 is now 0 comma -2. Now if I write y equals to -2 e to the power negative x and I add 4 to it, in all of these scenarios the asymptote remained where it was, and the asymptote will now move 4 units up as well as the graph. So now the graph, since moved 4 units upward, this will look like let me draw it with a different color. So the point which was initially 0 comma -2 is now 0 comma 2 after moving 4 units up. The asymptote, since it was already initially at y equals to 0, it also moved 4 units upward and now is at y equals to 4. The range of this function is y is less than 4. I hope I have made myself clear. This is all you need to know in this graph. Note that in this type of a question where there's a 4x involved, although the graph shape changes, but the shape is not significantly changing in sketching part. When you have to draw it on the graph paper, you need to plot the values automatically. But when you have to sketch it, the examiner, it doesn't matter to the examiner as long as you're just showing the x and y intercepts using your calculator and the shape of the curve. That's all about it. I hope I've conveyed myself clearly. Until next time, I'll see you again. Take care. Bye.